Hey there, future mathematicians. Today we're diving into the fascinating world of triangles. Triangles are everywhere. Look around you. See that window? It's probably made of triangles. How about that bridge over there? Triangles are helping hold it up. Triangles are strong. Their shape makes them stable. This is why they're used in building everything from houses to skyscrapers. But did you know that some triangles are extra special? They're called triangles and they're like identical twins in the world of geometry. Are you ready to unlock the secrets of congruent triangles? Let's go! Imagine you have two pieces of paper. These pieces of paper represent two shapes that we want to compare. You cut one piece of paper into a triangle shape. This triangle is our first shape. Now imagine you could perfectly copy that triangle onto the second piece of paper. You trace it carefully, making sure every line matches. You would have two triangles that are the exact same size and shape, right? These two triangles look exactly alike. That's what congruent triangles are. They are identical in every way. These triangles are like identical twins. Just like twins, they share the same features. Their corresponding sides are the same length. Each side of one triangle matches perfectly with the corresponding side of the other. Their corresponding angles are also equal. Every angle in one triangle is the same as the corresponding angle in the other. But how can we tell if two triangles are truly congruent without stacking them on top of each other? We need a method to compare them without physically overlapping them. That's where our congruence criteria come in handy. These criteria help us determine if two triangles are congruent by comparing their sides and angles. Mathematicians have developed special codes to identify congruent triangles. These codes are like a secret language that helps us understand the hidden relationships between different triangles. By using these codes, we can determine if two triangles are exactly the same in shape and size, even if they are oriented differently or located in different places. Think of them as secret handshakes for triangles. Just like a secret handshake can identify members of a club, these codes help us identify congruent triangles. We have 5 main codes: SSS, SAS, ASA, AAS, and HL. Each of these codes represents a specific set of conditions that, when met, guarantee that two triangles are congruent. If all 3 sides of one triangle are equal to the corresponding sides of another triangle, they're congruent. This is known as the side-side-side SSS postulate. It's like saying if you have 3 matching puzzle pieces, they will fit together perfectly. If 2 sides and the angle between them in one triangle are equal to the corresponding parts of another triangle, bingo, they're congruent. This is called the side-angle-side SAS postulate. Imagine having 2 sides of a triangle and the angle where they meet. If these match another triangle, the triangles are identical. If 2 angles and the side between them in one triangle match those in another triangle, we've got congruent triangles. This is the angle-side-angle ASA postulate. Think of it as having 2 angles and the side connecting them. If these match another triangle, the triangles are the same. 2 angles and a non-included side matching up, congruent triangles. This is known as the angle-angle-side AAS postulate. It's like having 2 angles and a side that is not between them. If these match another triangle, the triangles are congruent. This one's just for right triangles. If the hypotenuse and one leg of one right triangle are equal to those of another, they're congruent. This is called the hypotenuse leg HL postulate. It's like having the longest side and one other side of a right triangle. If these match another right triangle, they are congruent. These codes help us quickly determine if triangles are congruent, even if they're not lying right on top of each other. Pretty neat, huh? By using these simple yet powerful rules, we can solve complex geometric problems with ease and confidence. So, next time you see a triangle, remember these secret codes and unlock the mysteries of congruence. Section 4. Congruent triangles in action, real-world wonders. Congruent triangles aren't just a cool math concept, they're essential for tons of real-world applications. Think about architects designing sturdy buildings. They rely on congruent triangles to ensure stability and even weight distribution. What about engineers building bridges? They use congruent triangles to make sure the bridge can handle the weight of cars and trucks. Even furniture makers use congruent triangles to build chairs and tables that won't wobble. Section 5. Let's get hands on your triangle challenge. Today we're diving into the world of triangles with an exciting and interactive challenge designed just for you. Ready to test your triangle knowledge? This challenge will help you understand the properties and construction of triangles in a fun and engaging way. I've got a fun challenge for you. It's time to put your geometry skills to the test and see how well you can apply what you've learned. First, grab a piece of paper, a ruler, and a protractor. These tools will be essential for accurately drawing and measuring your triangles. Next, draw a triangle with the following measurements. Side 1, 5 centimeters, side 2, 7 centimeters. Make sure to be precise with your measurements. And the angle between side 1 and side 2, 60 degrees. This specific angle will help us create a unique triangle. Now draw a second triangle using the SAS code. SAS stands for side angle side, a method used to construct triangles. Make sure two sides and the included angle match your first triangle. This ensures that both triangles are constructed using the same criteria. If you follow the SAS code, your triangle should be congruent. Congruent triangles have the same size and shape, proving your construction was accurate. Great job. Section 6. Keep exploring the world of triangles. Congratulations! You've unlocked the basics of congruent triangles. You've learned what they are, how to identify them, and why they matter in the real world. But this is just the beginning. There's a whole universe of geometry out there waiting to be explored. Keep asking questions, keep experimenting, and keep having fun with math. Remember, kids, everything is made of shapes. And when you understand shapes, you can understand the world.